Hi everyone, we'll be looking at linear programming problem using Simplex method. The question says solve the following linear programming problem using Simplex method. And we have minimize z equal to 8x1 minus 12x2 subject to 4x1 plus 3x2 less than or equal to 24, 2x1 plus x2 less than or equal to 10, where x1 and x2 is greater than or equal to 0. So to solve this problem, we need to convert this inequality to an equation and also add our slack variable. We have 4x1 plus 3x2 plus x1 equal to 24. And for the second constraint, we have 2x1 plus x2 plus our slack variable s2 equal to 10, where x1, x2, x1, and x2 is greater than or equal to 10. After adding your slack variable, we also need to add the slack variable to our objective function, which is here. Therefore, we have minimize z equal to 8x1. So this is our objective function, 12x2 plus we have 0x1 plus 0x2. So the next thing to do is to represent this on a table. From our table here, we have our Cj here, which is the coefficient of the objective variable. We have our basic variable here. We have our Cb, and we also have the solution and the ratio. We have the Cj. So to represent these, our Cj will be the coefficient of the objective function. So from here, we have our objective function to be 8 minus 12, 0, and 0. So we are going to represent that on the table. So we have 8 here. We write 8. The next one is minus 12. We write minus 12. We have 0 and 0. 0x1 and 0x2. So for this row, we have 8x1. We write x1 here. We have x2 here, therefore we write x2. x1 and x2, we are going to represent that here. So we write x1 and x2. For here, we need to write the constraints given to us. So this is our constraint here. So this is our constraint 1, and this is our constraint 2. We have 4x1, 3x2, and x1. So we have 4, 3, and 1 here. So under x1, we'll write 4. We have 4 here. The next one is 3. We have 3. The next one, x1, we have 1. There is no value for x2 here, therefore we represent that with 0. We have 0 here. For the second constraint, we have 2. Under x1, we have 2. For x2 here, the coefficient is 1. We have 1. There is no x1, so write 0. We have 0 here. For x2 here, we have 1. We write 1. For the solution part, we have our constraint 1. We have 24 here. And for the second constraint, we have 10. We have 24 and we have 10. So from here, we'll look for our basic variable. To find your basic variable, the identity matrix forms your basic variable. So here, x1 and x2 forms the identity matrix because here we have 1, 0, and 0, 1. So here we write x1 and x2. The value for x1 here is 0, and the value for x2 is 0. Therefore, we write x1 here 0, and here x2 here 0. So the next is to find our zj. To find the zj, this is the formula for zj. CB inverse of BAG. So to find ZJ, we multiply 0 times 4, we give us 0. 0 times 2, 0. 0 plus 0, we have 0. For this, we have 0 times 3, which will give us 0. 0 times 1, 0. 0 plus 0, we have 0. For this, we have 0 times 1, 0. 0 times 0, 0. 0 plus 0 will give us 0. 0 times 0, 0. 0 times 1, 0. 0 plus 0 will give us 0. 0 times 24, 0. 0 times 10, 0. 0 plus 0 will give us 0. So here is the same thing as our z. That's our zeta is equal to 0. The next is to find our radius cos. To find the radius cost, we have Cj minus Zj. To find our radius cost, the formula is Cj minus Zj or Zj minus Cj. I'm using this first formula. So for me to reach the optimal solution, my radius cost, which is Cj minus Zj, will be greater than or equal to 0. So when I have something greater than or equal to 0, I've reached my optimal solution. Therefore, everything here will be tends to positive. That's greater than or equal to 0 will be 0, 1, 2, 3, 4, and thereabouts. If you are using this formula, which is Zj minus Cj less than or equal to 0, for you to reach your optimal solution, the number should be less than or equal to 0, or the number will tends to negative, right? So we have here 0, minus 1, minus 2. So if you have something negative, you've reached your optimal solution. But if you have to use this formula, when we have everything to be positive, we've reached our optimal solution. So I'm going to explain that for you so that you understand. Since I'm using this formula, which is Cj minus Zj, that means this is Cj and this is Zj. That's 8 minus 0, we have 8. Minus 12 minus 0, we have minus 12. 0 minus 0, we have 0. 0 minus 0, we have 0. Since we still have negative here, because I'm using this formula, we need to find our second table. The next thing to do is to find our ratio. And to find the ratio, we consider the reduced cost with the lowest value. From here, our reduced cost, we have 8 minus 12, 0, 0. So the least value here is this column, minus 12. This is our key column. This is our key column or the pivot column. The next is to find the ratio. The ratio, we do solution all over the key column here. So here we have 24 all over 3, which will give us 8. And for this, we have 10 all over 1, which will give us 10. So the next is to find our key row or the pivot row. So to find your key row, you take the smallest value here. We have 8 and 10. The smallest value is 8. This is our key row or pivot row. After your pivot row, you find your pivot element or key element. So here 3 is our key element or pivot element because this is where the column and the row, this is where they join together. So from here, x1 is our leaving variable and x2 is our entering variable. So that will lead us to our second table because we've not reached optimality because we still have this negative value. Because we're using this formula, for us to reach optimality, all the values here should be greater than or equal to 0. So we have a negative sign here. So we need our second table. So this is our first iteration. So we're going to represent everything here. This 8 minus 12, we are going to write everything. So nothing changed here. We have 8 here, minus 12, 0, and 0. For BV, we have x1, we have x2, we have x1, we have x2. Remember, x1 here is the leaving variable, while x2 here is the entering variable. So we are going to replace this with this. So we have our x2 to be here. We have x2 and we have x2 here. So we don't need to change this. So the next is to divide these values with the pivot or key element, which is 3. So here we have 4 over 3, 3 over 3, which is going to be 1. The trick here is the key elements or the pivot elements must be 1 in a new table. For this to be 1, we need to divide it by itself, which is 3 over 3, which will give us 1. And it applies to other values here. So we have 4 over 3 here, 4 over 3. We have 1. We have 1 over 3. For here we have 0. We still have 0. For here we have 24, which is going to be 24 over 3, which will give us 8. So we have 8 here. The next is to find the value for x2. So to find the value for x2, I'm going to show you the trick on how you can find your new value. So what we need to do here is we are going to write, remember this is our pivot element or key element. We are going to write out this number, which is x2. We're going to write this number x2. So we are going to write them down. We'll use that to find our new value. This is the number for x2 and this is the value. So to find the new number, remember this is our key element or pivot element. So the trick here is to multiply the pivot elements with the opposite sign of the adjacent value. So the adjacent value here is 1. If we are to multiply these key elements with the opposite adjacent value, so we have times minus 1 because this is plus 1. The trick here is we want the combination of these two values to give us 0. So for it to give us 0, we have 1 times minus 1, which is minus 1. Minus 1 plus 1 is going to be 0. The same thing applies to other values here. We are going to multiply here minus 1. We'll multiply here minus 1 times minus 1 times minus 1. So with this, we get our new value. So we have here 1 times minus 1 minus 1. Minus 1 plus 1 will give us 0. For here, we have 4 over 3 times minus 1, which will give us minus 4 over 3. Minus 4 over 3 plus 2, which will give us 2 all over 3. So we have here 1 over 3 times minus 1, which will give us minus 1 over 3. Minus 1 over 3 plus 0, which will give us minus 1 over 3. 0 times minus 1, which will give us 0. 0 plus 1, which will give us 1. We have 1 here. For this, we have 8 times minus 1 minus 8. Minus 8 plus 10, we have 2. So this is the value for this new x2 here. For x1 here, we have 2 over 3. The next value, we have 0. Just note that the number here coming after the element will be 0. So the next value here is minus 1 over 3. We have minus 1 over 3. The next one is 1 and 2. We have 1 and 2. The next is to find the coefficient of x2 and also x2 here. The coefficient of these, we have minus 12. Therefore, we write minus 12. For x2 here, we have 0. The next is to find our zj. To find our zj, we say minus 12 times 4 over 3, which will give us minus 16. 0 times 2 all over 3, which will give us 0. Minus 16 plus 0, we have minus 16. For these, minus 12 times 1, which will give us minus 12. 0 times 0, 0. Minus 12 plus 0, we have minus 12. For these, minus 12 times 1 over 3, which will give us minus 4. 0 times minus 1 over 3, which will give us 0. So we have, when we combine the two, we have minus 4. For here, we have minus 12 times 0, which will give us 0. 0 times 0, 0. We'll combine the two, we have 0. So for this, we have minus 12 times 8, which will give us minus 96. 0 times 2, which will give us 0. Minus 96 plus 0, we have minus 96. So this is just our zeta, which is minus 96. From here, we observe that we've reached optimality because here, all the values here, they are 0 and less than 0, which because we have minus sign. So we have reached optimality because here, every numbers here are negative. We don't have any positive values again. Assuming you are using, zj minus cj, all the values here should be positive for you to reach your optimal solution. So here we are going to confirm if this is correct and if you're on the right track. So here we'll write our x transpose. Our x transpose is the values we have in our solution. We have x2 to be 8. We have this x2 here to be 2. There is no value for x1. We write 0. For x2 here, we have 8. Therefore, we will write 8 here. For x1, 0. For x2, we have 2. Therefore, we write 2. So this is our x transpose. So to get our optimal solution now, we are going to substitute this value into our objective function, which is here. Or we use this. So we're going to substitute this value, this S transpose we got, into this. Remember here, our S transpose, we have x1 to be 0. We have 8 times 0 minus 12 times. So x2 here is 8. We have 12 times 8. plus 0 times no value for, we have 0. For x2 here, we have 2 plus 0 times 2. So we're going to multiply this and, do the summation here. We have 8 times 0 will give us 0 minus 12 times 8 will give us 96 plus 0 times 2 will give us 0. Therefore, here we have minus 96. Our optimal solution is minus 96. And when we compare these two answers with these we got, we see that is the same value. So here our optimal solution is minus 96. So we've come to the end of this tutorial. Like the video, subscribe, and I will see you in my next lesson. Bye.